At noon, ship A is 20 nautical miles due west of ship B. Ship A is sailing west at 21 knots and ship B is sailing north at 24 knots. How fast in knots is the distance between the ships changing at 4 p.m.? 1 knot is a speed of 1 nautical mile per hour. Round your answer to 2 decimal places. All right, let's see what we can do here. So north and west are the directions that we're interested in. So just going to sketch a picture here. I have ship A sailing west at 21 knots, but it's already 20 knots due west of ship B. So ship B starts here, and we can say ship A starts here, which is 20 knots away. So let me just kind of, that's 20. And then the rate of change is, we'll say dA dt, and that's 21 knots. Then B, of course, generally starts here, but it is moving at a rate of 24 knots. So I'll just move it up this way, just so we take into account that it is moving. All right, now what we're interested in is the distance that is between those points at a specific point in time. And that point in time is 4 p.m. So at 4 p.m., 4 hours have elapsed because this started at noon. So ship A, we'll say at 4 p.m., ship A is at, so 4 hours later, 20 miles plus 4 times 21 knots. So grab the calculator, make sure I don't make an arithmetic error here. 20 plus, oops, there, I'll just make an arithmetic error on the calculator instead. 4 times 21, so 104 knots of travel. Oh, and you know what? This should have been like knots per hour, since that's a change in time. And ship B is starting at 0. It's started here initially. So after 4 hours, it's just whatever its speed is times the 4 hours. So 4 times 24, I think that's 144. Let me double check. Oh, good thing I checked because it's 96. All right, so 96 knots. All right, so that's the distance at 4 p.m. That's how far away these ships are at 4 p.m. Now, of course, we have the relationship s squared equals a squared plus b squared. So this is a Pythagorean theorem relationship between these two variables. So what we need to do is figure out how they're changing at this particular point in time. And by changing, that tells us we need to find a derivative. And we're changing with respect to time, so we're going to differentiate implicitly with respect to time. So when I differentiate this formula implicitly, the derivative here would be starting with s squared. S squared is an outer function. We differentiate that as we would normally, but we multiply by the derivative of the inside part. And then a squared and b squared, we would have 2a dA dt plus 2b dB dt, just using implicit differentiation. Now at 4 p.m., we know exactly where, or we know what this distance is. We know what this distance is. We've found those here and here. We don't know what S is, but we can figure it out through this relationship right here. So let's do that real quick. So we'll say S squared. So again, this is at 4 p.m. s squared is 104 squared plus 96 squared. And using the calculator there, so 104 squared plus 96 squared is that, and then I take the square root. Whoops, and I do the answer. Oh, second and answer. All right, so about 141.53. And I think what I'll do though, I'll leave it as just s equals the square root of 20,032 just for the moment, knowing that I can switch it down to 141 point whatever in just a bit, simply because I want to make sure I get the most accurate answer. So I'm going to avoid doing any operations that involves rounding until the very end. Now, what we're looking for to figure out is how fast the distance between the ships is changing. So that is the distance between the ships is ds, and we want to know how fast it's changing. So we're looking for ds dt. So that's the variable we're trying to solve for. And again, we know these other things. We know what dA dt and we know what dB dt is. We just have to plug in accordingly. So we know the value of all of our variables now except for ds dt, so we can solve for that. And we can say ds dt is 2 times a, so the current position at 4 p.m. of a, which is 104, times the rate of change, which with a is moving, so dA dt is 21 knots per hour, plus 2 times the rate of change of b, which is 96, times dB dt, and that is 24 knots per hour, all over 2 times s, which is the square root of 20,032. And I'll put all of that into the calculator and just get an approximation and see how we do here. So 2 times 104 times 21 plus 2 times 96 times 24 divided by 2 times the square root 20,032, and it looks like it 31.71. And that is in knots per hour, because that's a measurement of speed as well.